All right, so 11.2 and 11.3 usually we teach together. This video will just cover lesson 11.2. So 11.2 is going to be the area of parallelograms and triangles only. 11.3 is trapezoids, so we'll get that in another video. So we're just going to talk about the area of parallelograms and triangles in 11.2. So let's start off with the rectangle, right? That would be the basic one. We talked about it a little bit in 11.1. So if you remember, the formula for the area of a rectangle is area equals base times height or length times width. If you want to say that, that would be fine too. However you think of it, whatever vocabulary you use, they both mean the same thing, right? So here's a pretty straightforward rectangle. When we say base and we say height, we're really talking about base of 4 meters, height of 2 radical 2 meters, right? We know it's a rectangle, so that's how I know that these are all right angles, and that's where I'm getting my base and my height from, right? So if I had to find the area of this particular rectangle, I would do area equals 4 times 2 radical 2. Don't forget how to multiply with radicals here. Outside times outside. 4 times 2 gives me 8. Inside times inside. Well, there's only one inside, so it would be 8 radical 2. And don't forget to label your answer there. 8 radical 2 meters squared, right? Whenever I'm talking about area, it's units squared. So 8 radical 2 meters squared. Don't forget, even when you have a radical as part of your answer, you still need to label it. That radical 2 is not a label, it's a number. So don't forget that. Okay, hopefully that one was pretty easy. Area of a rectangle. What about this parallelogram then? What's the formula for area of a parallelogram? Well, in fact, it is exactly the same as the area of the rectangle. Area equals base times height. Now, length times width is still a little bit confusing, but again, that would work if you wanted. But I'm sure you're probably like, but why on earth could it have the same formula when it looks drastically different? So if you can see, I have my height drawn into this parallelogram here. And when you draw that height in, it kind of creates this triangle right here, right? Now, if you could picture slicing this triangle off of that parallelogram and moving it and attaching it over on this side right here. If I slice that triangle off and slide it over to attach it over here, let's see, then this ends up being a right angle, right? Here's that triangle. And I know that it's going to line up exactly because it's a parallelogram. So opposite sides are parallel. So I do know that there's not going to be any gaps or anything like that. So hopefully if you can figure out cutting off that pink triangle on the left, sliding it over on the right, and now you can see, boom, it is in fact a rectangle, right? Whatever I cut off on the left of the base, I slide it over and attach it to the right on the base. So that is still staying as 10 centimeters. So hopefully that helps you visualize why parallelograms and rectangles actually have the same formula. Now, if we were going to actually find the area of this one, hopefully that's pretty straightforward. So area would be base of 10 times height of 5. So area would be 50 centimeters squared. All right, so rectangles and parallelograms both have the same formula. Just be careful of what is the base and what is the height. All right, so then we have triangles is our last one here. Formula for area of a triangle. Again, I hope that you remember this from before, but area of a triangle is 1/2 of base times height. And the easiest way that you can really picture that is to picture a rectangle, right? For whatever the base and the height are of my rectangle, call this the base, this the height. If I take that rectangle and I make it into 2 triangles, I split it exactly in half, same base, same height, so the area would be 1/2 of base times height, 1/2 of base times height. So that's where that formula comes from. So don't forget the 1/2 for area of a triangle. So here I've got an isosceles triangle, notice. The 2 legs are 10 inches and the base is 12 inches. So I need to figure out the area of that isosceles triangle. So first question is, well, let's see, 12 would be the base and 10 would be the height. Except that 10 is not standing straight up and down from that base, right? When I have a height, my height needs to make a right angle with the base. So my height would have to be here, right? Oh, we've done enough isosceles triangles, I hope, that when we draw in the height here, we see that, oh, we've created two congruent triangles. You've got your sides imply angles. You could use HL, you could use angle, angle, side, however you want to do it. But hopefully now when we realize when we draw that altitude into an isosceles triangle, that it in fact splits that base into two congruent parts. So this would be 6 inches, and this would also be 6 inches. Now I need to figure out the height. Let's see. 10 would be 5 times 2. 6 is 3 times 2. 3 and 5. 5 is across from that right angle, so Pythagorean triple. 3, 4, 5. I have 3, I have 5. What I need is 4. So the height here would be 4 times 2, which would give me a height of 8. So now using my formula for area, the area of this triangle is 1/2 the base of the entire triangle. The whole base here is 12 times the height that we just found is 8. So let's see, 12, half of 12 would be 6 times 8, which gives me 48, and putting my label on it would be 48 inches squared. So you won't always be given the height. You may have to do a little work to find the height, but hopefully all of our work with those right triangles really helps you out here for these problems as well. All right, those are the formulas we're talking about today. Now we have a little bit of practice. So we've got 2 practice problems here. First one, I've got a triangle, and the second one, I've got a parallelogram, and we're trying to find the area of each one. So the first one, I've got triangle ABC. Now again, this is the triangle that we are trying to find the area of, right? All of this. That dotted line is just telling you how high point C is off of the ground, if you will, down here, side AB. So I only want the area of that shaded portion there. The tricky part of this is understanding what we mean by height. What we mean by height of a triangle is how far is it from the tallest point to the side across from it, forming a right angle. So if I call side AB the base down here, if side AB is the base, then point C is the opposite vertex. And I want to figure out at a right angle, how high up does point C go? So that would be like right here, right? At a right angle. Well, that's exactly what they're showing you right here is this 8 millimeters. 8 millimeters is how high up point C is away from side AB at a right angle. So 8 millimeters is in fact your height, even though it's not shown right smack dab in the middle of your triangle. So 8 millimeters is your height if 7 millimeters is your base. Now, yeah, you could turn that triangle and call something else, but I don't have any other given information. So I think that's going to be the easiest way to go. So the area of this triangle is 1/2 of 7 times 8. Let's see, well, half of 8 is 4. So area equals 4 times 7. 4 times 7 is 28. So the area is 28 millimeters squared. All right. Now I've got my parallelogram over here. Remembering what the formula is for area of a parallelogram. Area of a parallelogram is base times height. All right, so let's see, base times height. If I call 14 the base, is 6 the height? No, it is not, because I have a 60-degree angle over here, right? That's not a right angle. So I know that I need to draw in my height with a right angle. Oh, look at that. I have 90, I have 60, which means that this must be a 30, 60, 90 triangle. That could help. All right, so if I remember my 30, 60, 90, the side across from 90 is 2x. The side across from 30 is x. The side across from 60 is x radical 3. So if 2x is 6, x must be 3, in which case the height would be 3 radical 3. So my area of this parallelogram would be 14 times 3 radical 3. And again, remembering how we multiply fractions here, 14 times 3, outside times outside, I get 42. Inside times inside would be radical 3. There's only one radical 3. So I've got 42 radical 3. And on this one, there were no units given. You can say units squared if you want to, but if no units are given, that doesn't add anything. So we can just leave it without a label on that one. Hopefully that helps you see those plain old formulas in some more complex problems like you're about to see them.